Good afternoon. My name is Josh Ballenger, and today we will be discussing the ADTA 5250 Large Data Visualization Final Project. The final project is composed of several sections. The first section is a visualization that represents relationships between myself and 15 people. The second section consists of analysis and visualizations generated in Tableau on the Crime Data All CSV. The third section consists of analysis and visualizations generated in Tableau on the Sales Record 1 CSV. The fourth and final section is a series of visualizations created using Jupyter Notebook, specifically the Pandas library, analyzing the PIMA diabetes CSV. In the first section, a visualization was created to help describe the relationship between myself and 15 people. Personal and professional relationships were included. Shape and color were utilized to distinguish the relationship type. Line weight or thickness was used to distinguish the strength of relationships. Distance vertically from myself was also utilized to distinguish the strength of each relationship. In the above chart, you can see me at the center with lines branching out from me. As mentioned previously, shape and line color were utilized to distinguish the relationship type. Blue lines with circles represent personal relationships. Orange lines with rounded corner squares represent relationships that are both personal and professional. Green lines with green squares represent professional relationships. Dana B is a personal relationship. Bridget K is a personal and professional relationship, and Lisa W is a professional relationship, for example. The distance from me vertically, along with the line weight or thickness, represents the strength of each relationship. Dana B is next to me vertically and has the highest weighted line because she is my wife. The next row down that includes Sean E represents close friends and family, which are very strong relationships, but not as strong as the one with Dana B. The next row below that, which includes Laura B, represents friends and family, but ones which I have a weaker relationship when compared to the row directly below mine. Then on the bottom left of the graph, you have Alex R with a dotted and lightweight line. Alex is a long-term friend, but one that I have lost touch with in recent years. The relationship is there, but it's not near as strong as the other two personal rows. Moving above my name, the first row of orange boxes, which includes Derek L, represents people I have a professional and personal relationship with. I work with these people day to day, and we frequently also spend time together outside of work. These relationships have a similar strength as the second personal row, the one with Laura B. Above this row, the relationships I have that are professional only are represented. I work with these people a few times a week, but there's not a very strong relationship here, hence the lightweight line utilized for those lines. In the second section, we will be analyzing the Crime Data All CSV file utilizing Tableau. Multiple visualizations were created to help identify trends in the data and to help with the analysis. The volume of records is over 5.8 million, so visualizations were necessary to assist in analyzing the data. The records are recorded crimes from 2001 to 2015. The data set is massive. Again, it has 5.8 million records. There are 22 variables total. For this initial analysis, we utilized 5 of those variables. The count of records was utilized to represent the number of items on each graph. FBI code was used to distinguish between the different FBI codes assigned to each crime. Primary type was also utilized in this capacity along with description. The date was utilized on several visualizations to demonstrate the trends in crime over time. The purpose of this visualization was to identify a count of how many crimes were assigned to each primary type and then to each FBI code. FBI codes can appear under multiple primary types. A color gradient was assigned to the variables to help identify the worst or highest versus the least or lowest crime primary types. The middle of this gradient was shifted to the average of the displayed values to better demonstrate the variances present. In the screenshot, we can easily identify the worst present as a combination of battery and 08B. However, if you open the Tableau workbook, you can see that theft with a code of 06 is much higher with over 1.2 million associated records. We also have a screenshot of the summary statistics above showing over 5.8 million records total with an average count of 104,693. The least recorded crime only contains one record per the minimum, and the highest recorded crime contains 1,211,080 per the maximum. The purpose of this visualization was to identify a count of how many crimes were assigned to each primary type, then each FBI code, and then to description. FBI codes and descriptions can appear under multiple primary types. A color gradient was assigned to the variables to help identify the worst or highest versus the least or lowest crime primary types. The middle of this gradient was shifted to the average of the display values to better demonstrate the variances present. In the screenshot, we can easily identify the worst present as a combination of assault 0, 8A, and simple. However, if you open the Tableau workbook, you can see that theft with a code of 06 and a description of $500 and under is much higher with 466,436 records. We also have a screenshot of the summary statistics above, showing over 5.8 million total records with an average count of 14,620. The least recorded crime only contains one record per the minimum, and the highest contains 466,436 per the maximum. The purpose of this visualization was to identify the count of how many crimes were assigned to each primary type. Each primary type is identified by a color. The screenshot is fairly small in order to fit in this presentation. However, in the screenshot, we can easily identify the worst present as theft. We can also easily identify the top 4 crimes per the graph as being battery, criminal damage, narcotics, and theft. If you open the Tableau workbook and go to this chart, you can also place your cursor over each graph to see the specific count behind each. Motor vehicle theft, for example, in pink, has 278,739 records. The summary statistics again let us know that there are over 5.8 million records, with the average being about 167,508, the max of 1,211,080, and the min of 1. With this visualization, we have a record of all crimes committed year over year from 2001 to 2015. We can immediately see that the number of crimes is decreasing each year, with the sharpest decrease from 2014 to 2015. Again, this visualization had to be shrunk to fit into the presentation, but if you open the workbook, you can see the individual counts for each year next to each corresponding dot on the line. With the summary statistics, we have over 5.8 million records, all records show. We have an average of 390,853 crimes per year, with a minimum of 151,632 and a maximum of 486,703. The maximum actually belongs to 2002, and the shift from 2001 to 2002 represents the only increase year over year for this set of records. This visualization was set up to identify the top 10 crimes via a filter and to plot them with each being uniquely identified in the graph. Using the filter to identify the top 10 allows us to pull those variables only into the graph. They are assault, battery, burglary, criminal damage, deceptive practice, motor vehicle theft, narcotics, other offense, robbery, and theft. Plotting these crimes in this manner allows us to identify the trends year over year. For example, we see that theft actually increased a few times throughout the period reported, such as from 2007 to 2008. Overall, each crime shows a decrease year over year. However, that decrease is much more pronounced with the top 4 crimes, which are theft, battery, criminal damage, and narcotics. The filter in this graph within the Tableau workbook can also be used to home in on other crimes. The filter can be adjusted to show the top 5, the bottom 5, etc. In the third section, we will be analyzing sales records 1 CSV file utilizing Tableau. 2 visualizations were created to help analyze sales and profit. The scatter plot visualization was selected due to it being an effective way to visualize multivariate data points. The dataset has 9,994 total records. There are 21 variables total. For this initial analysis, we utilized 5 of those variables. A sum of sales along with a sum of profit was utilized on the X and Y axis in both visualizations. Category, region, and segment were identified through shape, color, and size to help us distinguish them within each scatter plot. The first visualization identifies the total sales and total profit per category and region. Category is represented by different colors, with blue for furniture, red for office supplies, and gold for technology. Region is represented by different shapes, with circles for central, squares for east, pluses for south, and X's for west. Some quick observations are the fact that high sales do not necessarily equal high profit. Furniture maintains a low profit even with higher sales. This could be due to the high overhead of furniture and discounts being offered on furniture. We can also observe that the higher the sales in technology, the higher the profit. While looking at the regions, we see that the West is trending high in all categories, while South is trending low in all categories. We can also see that the Central region has a loss in regards to profit within the furniture category. The second visualization identifies total sales and total profit per each category, region, and segment. Categories represented by different colors, with blue for furniture, red for office supplies, and gold for technology. Region is represented by different shapes, with circles for central, squares for east, pluses for south, and X's for west. Segment is identified by size, with consumer being the largest, corporate being in the middle, and home office being the smallest. The trend of furniture having low profit even with high sales is again evident. We even see two different distinct furniture, the blue icons, with a negative profit. The grouping of highest sales and profit items belongs to the consumer market, with the mid-range being made up by corporate and the lowest in each sales and profit being made up generally by home office. Adding in segment allows us to focus marketing on areas that have the most success, i.e., the consumer market. And if you want to be more specific, the technology in the consumer market has the highest sales and profits in the East and West. In the fourth section, we will be analyzing the Pima Diabetes CSV file utilizing Python and Jupyter Notebook, specifically the Pandas library. 4 different types of visualizations were created. Each is useful in helping identify trends in early data exploration. Histograms, density plots, box plots, and scatter matrix were all created. The dataset has 768 total records. There are 9 variables total, with each included in the visualizations. Before we could create any visualizations, it was necessary to upload the CSV to the appropriate folder. Then we had to import Pandas and scatter matrix in order to utilize them in the rest of the code. With Pandas imported, we were then able to load the data into a data frame for analysis. However, it was also necessary to assign header names, as the original file did not contain headers. We then displayed the headers in top 5 records to ensure they were imported successfully. We loaded the data into a data frame called df_pima, which will allow us to easily recall the data as we create each visualization. Screenshots of the visualizations are provided. However, for a higher resolution view, please open the ADTA 5250 Final Project Pima Diabetes IPYMB or Jupyter Notebook file. The first visualization we created was a histogram for each of the 9 variables. This helps us identify how each data point is distributed. Age, preg, skin, and test are all skewed to the left. Mass, plas, and pres are all fairly evenly distributed on a normal curve, and class is shown to be a binary variable. One command utilizing Pandas will automatically create a histogram for each numeric variable. The command is pictured below the bullet points. The second set of visualizations we created was a density plot for each of the 9 variables. The first one represents all data points on one plot, but due to the large variation in density, it is not as helpful as one variable class is not as helpful. One variable class has a much higher density max than the others. This helps us identify how each data point is distributed. Class and skin have 2 relatively high peaks, which are readily evident in these visualizations. We also see secondary minor peaks with mass and pres. The command used on input 6 above will plot each density plot on the same graph. However, we needed an individual of each plot due to the high variance in density between the variables. Input 7 demonstrates how to create a density plot on a specific variable. This command was run on each of the 9 variables to generate the needed plots. The third set of visualizations we created was a box plot for each of the 9 variables. The first one represents all data points on one plot. Subsequent ones are each variable run by themselves. This helps us identify how each data point is distributed and potential outliers in each variable. We see some outliers in each of the variables, but by far test variable has the most outliers and the most statistically significant outliers. It also contains the largest potential range of the variables overall. The command used on input 16 above will plot each box plot on the same graph. However, we needed an individual of each plot due to the high variance in the distribution between the variables. Input 17 demonstrates how to create a box plot on one specific variable. This command was run on each of the 9 variables to generate the plots needed. The fourth and last visualization we created was a scatter plot matrix of all the variables. This allows us to use multivariate analysis to compare each variable to one another. This in turn allows us to visualize the trends between any 2 given variables. Today we discussed 3 different ways of visualizing information. We demonstrated how a visualization can help distinguish between personal and professional relationships along with identifying the strengths of those relationships. We utilized multiple visualizations with Tableau to analyze the FBI crime data and sales records files. Then we utilized Jupyter Notebook, specifically Pandas, to help early data exploration on the Pima diabetes dataset. Each of these tools can be used on a variety of datasets, whether needing to map out relationships between items or explore large datasets to identify overall trends all the way down to the specific data points. Thank you and have a good day.